Hi, I want to spend time with you today talking about how to find a delta value graphically to satisfy the definition of the limit. In one of these problems, you'll either be given a graph or asked to construct a graph. I'm going to give us the graph in this case of a function f of x. I've been given a point of interest minus 4, and I want to say given epsilon equals 0.1, find a delta greater than 0 so that, okay, and now the definition of the limit is inside of here. So here's an arbitrary epsilon. Your mission is to find a delta. You should be able to find delta no matter the epsilon we gave you. So given an epsilon, find a delta so that if the absolute value of x minus 4 is less than delta, then the distance between f of x minus 11 is less than 0.1. Okay, so here's epsilon. This one right here, this is L. Your mission is to find this. This is the value A. This is A. That's an A. That's an A. A. L. F of x. Okay. So our mission is to find a delta so that if we're no further than delta, then we're guaranteed to be within epsilon of L. So I'm going to wipe that away here because my focus here is on the process, not necessarily the statement of the definition. Nonetheless, I felt it was important to repeat the definition inside of this video because, well, it's kind of a foreign statement, and I think it's important that you internalize at least some of that statement. Okay, so we're going to be, say, given an epsilon equals 0.1, find a delta. So that, okay. So what I'm going to do is kind of think about this, think about the steps to this thing. So I feel like as a precursor, we need to identify L and A. L always lives on the vertical axis. A always lives on the x-axis. Okay. A always lives on the x-axis, and L always lives on the y-axis. 2, I think what I'm going to want to do is draw the gap, or what I think of as the window. What that means is that I'm going to go over here, and I'm going to go off a distance right here of 0.1. I'm exaggerating the distance 0.1 on this because this is a training video. So that's where epsilon is. And I'm going in both directions from my L value, vertically and below. So that's go up and down from L by epsilon, a distance epsilon from L. And I think we should propagate that left. No, I want that to be an orange. And we're going to propagate it left or right, like toward the function. Okay, so I'm going to take that, and I'm going to go boop, 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 horizontally, and I'm going to mark those points of intersection. That one right there, and that one right there. I'm going to go down from those points of intersection. So Now we're going to draw a vertical window. And so I'm going to go down from my intersection points. So I'm going to go down from this one, and I'm going to follow it down. Okay, so follow that one down, and I'm going to follow this one down. Okay, so that's my vertical window. I'm going to call this x sub min and x sub max, these 2 points. I'm going to identify x sub min and x sub max, how far away I can make them be. And then I'm going to let delta be equal to the minimum of I'm going to let delta be the less of delta is going to be the smaller of a minus x sub min and x sub max minus a. Those 2 values. Okay. So suppose that I find that this value here, this x sub max, is equal to 4.02, and x sub min is equal to 3.96. So that's a minus. Nope. I have to try again. Do you see how what I wrote there was wrong? So x sub max is actually on the right-hand side. And so that would be 4.02 is over there. So because of the sign, my numbers here were wrong. I'm leaving that in the video deliberately because I want you to see that, like, I'm not perfect. That the particular flavor of the mistake I made is because I'm working on the negative x-axis. Okay, so let me try again. Okay. I want x max to be closer because based on the window here, x max is closer than x min. Okay, so x max is equal to minus 3.98, and x sub min is equal to minus 4.04. So this is minus 3.98 and minus 4.04. Now, there are 2 distances here. There's a distance there and a distance there. They're not the same. It's not the same from the left and the right. I want delta to be the smaller of those 2 distances. So this distance right here, this distance is the difference between minus 3.98 and minus 0.4. This distance right here is going to be delta right. And that's equal to 0.02. This distance right here is delta left, which is equal to 0.04. Those are always going to be positive values. You're never going to get a negative because they're distances. Distances are always positive, never negative distances. Okay. So in order to conclude this problem and figure out what delta should be, we're going to go, then we're going to let delta be equal to the smaller of 0.02 and 0.04. And the smaller of those two values is 0.02. So in principle, I read these values off of my axes that I was given. I was given this on a paper prop. I was given this on paper, and it's labeled right here, and I can read those values off of this piece of paper. Okay, or maybe I have to go into a calculator and figure out how far I can go to the left and stay within this as well. Okay, so now. As long as I'm no further as 0.02 away from -4, then I'm inside this. So as long as I'm inside here, then when I go up and find my function values, I'm inside this window. As a kind of concluding note to this problem, we chose the smaller, so like you could have gone further to the left. But the definition doesn't care about sightedness. It just is like, there should be one so that no matter how far away you are in either direction, as long as you're within the delta value, then your function values are close. Okay, so let's sum up the steps for what I did. I was given a graph and some labeled values. I was given an epsilon, and my mission is to find a delta. So to get started, I think it's important to place L on the y-axis and A on the x-axis. X is approaching A, F is approaching L. I'm going to go up epsilon and down epsilon away from my value L. Epsilon always lives on the vertical axis. I draw my band to the left. I find my intersection points. I'm going to drop lines down and find where they hit the x-axis. I'm going to find the distances between A and the right and left points. They might not be the same thing. They're probably not the same thing. In fact, they'll generally only be the same thing if this is a line. If it's not a line, it's likely that they're not the same. I'm going to go a little bit. I'm going to find these x coordinates here by dropping down these intersection points. I compute the distance between A and the left and right points. And then I take delta to be the smaller one. And then I'm done, and that's my delta. And that guarantees that if I'm within delta, inside of this, then when I go up and figure out my function value, I'm inside this vertical window right here. Okay? So that's kind of a general procedure for approaching one of these graphical find the delta type problems. And it works kind of no matter how wavy the function is and stuff like that. Like, as long as graphically the limit exists, this process is going to work, and you'll be good to go. So thank you so much for your time in watching this video, and I wish you all the best. Thank you.